In this series, we're going to cover implementing HTTP functions using the serverless technologies of the various major cloud providers. This essentially means Lambdas in AWS, Azure functions in Azure, and GCP cloud functions. This series complements the Scaling in the Cloud series, and that series deployed a simple microservice using Python and Flask framework. And what we did is we deployed them with virtual machines or EC2 instances, and we would scale up the instances as the load increased and scale down as the load decreased. So what we're going to do is we're going to take the code that we did, we're going to adapt it. It was Flask code, and we're going to adapt it for the serverless functions and the various providers. It's not quite Flask. It's pretty much the same code. So you'll see sort of tongue-in-cheek in the materials where I call it flasky or Flask-like. And the goal is to deploy an identical API from the Cloud Scaling series using the native cloud features of each cloud provider. So by the end of the series, you should be able to learn how to deploy a Python-based HTTP endpoints across all three major cloud providers. And we're going to walk through a couple of tasks. The first one is we're going to deploy Python code for microservices using serverless technologies. That's Lambda for AWS, Azure Functions for Azure, and Cloud Functions for Google Cloud. Like the original series, we're going to use a document database for microservice data storage. That's very simple. It's storing a list of names and getting them. And we're going to use sort of the cloud native document database provided by each provider. So for AWS, it's DynamoDB, for Azure, it's Cosmos DB, and then it's Firestore for GCP. Then we're going to attach HTTP endpoints to invoke the serverless code we deployed. Now that's API Gateway for AWS, Function App for Azure, and then Google is a little different because we've discussed in previous videos how Google likes to keep the simple cases simple. There is such thing as a API Gateway, but for our very simple case, we do not need to use it. Cloud Run fits the bill. It routes every traffic as we expected. So we're going to do the simple case. I'm thinking about doing another video on securing these APIs with either Okta or Ping or one of those providers. And that you would have to use a gateway for GCP. So the next thing we're going to do is we're going to secure the HTTP endpoints. The first time we deploy the code, it's going to be public. Anybody can access the endpoints. And so there's some cloud native ways to secure the endpoints. There's IAM integration for AWS, and we'll show you how you set the headers for that in Postman. There's function keys for Azure, which are pretty basic. Probably the least secure of all the native cloud providers. And then you use the JWT token, or I guess it's the JSON web token for GCP, which is sort of a variant of OAuth, which ultimately, in the wild, you're probably going to use OAuth in some capacity to secure APIs. But the cloud providers do provide these basic things, and we will cover them. Then at the end, we'll clean up the resources by destroying all the infrastructure. So at this point, you might want to go look at the description of this video, and you'll have the GitHub link to all these materials. You may want to go grab that now so you can follow along. There'll be a quick link section which has all the videos, so you can go to the individual videos. But let's talk about serverless computing. Serverless, it's kind of a misnomer. They say it's serverless, and you might say no servers, but that's not the case. It's simply that you don't deploy the servers. The cloud provider deploys the servers for you and handles the scaling, and then you only pay as for the number of requests that you use. Another way to think of serverless is it's the smallest amount of compute you can buy from these cloud providers. And essentially what you do is you give it some code, or give the cloud providers a code, and it will invoke that code on various triggers. Now the trigger we're going to use is HTTP. But there's step functions, there are timers, there's stream processing. There's all sorts of ways that these are using, but the HTTP endpoints are what we're going to use as our trigger. And so that's for AWS. It's AWS Lambda that runs code, integrates it with API Gateway. API Gateway is which implements the HTTP endpoints. It defines the routes. It does parsing of the parameters for you. And so we have a sort of a diagram of the AWS solution, and that includes the Flasky gateway, and then it has a series of routes defined, and those routes go to the 4 endpoints: the good to go, the candidates, candidate get, candidate post, and it's interacting with a DynamoDB table to actually store the data. Of course, it's available on the internet. Then we've got the Azure solution. In Azure, there's Azure Functions, and there's a function app. And the function app is what glues it all together, gives you the HTTP routing and requests. When we look at the code, you'll see that it's a little bit more like Flask in that you have one Python file and the routing is actually in the code. And so here is the diagram for that. It looks very similar to the other ones. You have the function app, which sort of acts as the gateway, is the same as AWS, and it's routing to those 4 endpoints: good to go, candidates, candidate get, candidate post, and then it's interacting with the Cosmos DB table to actually store the data. So the last one we'll cover is the Google Cloud Platform, and it is by far the simplest to get started, which is in line with what we've observed with other things with Google Cloud. They like to keep the simple case simple. So Cloud Functions give us everything we need. You've got HTTP endpoints that get triggered. Now you can use an API gateway, but we just didn't need it for this example. Where you would need it was better routing, authentication, rate limiting, and logging, where that gives you better features. And if we did the OAuth integration with Okta or Ping, that's where we would do that. So its diagram is very similar. You've got the internet and the cloud functions that are running under Cloud Run. The only thing that's a little different is there's a candidate function, and the candidate function includes a get and a post and one, so that since the other ones have separate endpoints or separate modules, it has one module that does it. And then it's interacting with the Firestore database. So let's talk about languages. We're going to use Python. I typically, with the serverless examples, I go with the interpretive language, not the compiled languages, because generally, if you're going to do a compiled language, you have to manage the compilation and uploading the zip, which is not hard, but I just always like using the interpretive languages. So they support a bunch of languages out of the box. You've got Node.js, Python, Java seems to be sort of the common base. But then they have other ones, PowerShell, Go, and it's a little bit different. But at the end of the day, they also have the ability of doing custom runtimes. So these custom runtimes, you can be any language. There's a little more work, but like Rust is an up-and-coming language. I'm sure they'll add the out-of-the-box, but you can add Rust for a custom runtime. Okay, so let's talk about securing these serverless APIs. By default, when we deploy them, we'll deploy them once, and then we'll deploy them a second with some sort of security or some sort of securing them. And there's 3 different ways of doing it. Now, these are lightweight methods, and a lot of examples you're probably going to use OAuth, like we talked about. And I'm thinking about doing a video just for that. But for AWS, you create a IAM user with an access key and secret, and you give it access to the function, and then you use this AWS SIG4 toolkit, which Postman supports, which we'll show you, for creating the headers necessary to authorize. And it's fairly secure, and there's libraries for doing it, because if you leak the signing, the token's only good for so long. So it's decent. Then you have Azure Functions. This one's a little more janky because it uses these keys, and the keys are static. You can rotate them, but if you leak the keys, people can have keys to the kingdom. But it is one way of securing it, and you can rotate the keys. You can manually do it. It's just the keys aren't like time-bound like the other ones, where you get a token, and it's valid for an hour or whatever, and then it expires. Then the final one is Google Cloud Functions, and that uses auth tokens, a JSON web token, which is kind of a variant of OAuth, like a service authentication through OAuth, and you retrieve that through Google Cloud Auth command, and then you put it in the header. And again, for all 3 of these, we're going to implement our API anonymous. then turn on security and show you how you interact with the service with headers once you've turned on security. So I've got the Flask-like endpoint summary. We'll do a very quick demo. I have deployed an AWS version. So you run the validate script here, and then you can take this guy right here and pop that into Postman, which I think I've already done, and do send. And you see that that runs the API. Then there's candidates, which will give you all the candidates. And then there is a candidate where I can say homie, and it'll load just one candidate. And then finally there are a post. If I want to add homie2, I hit homie2, and then go back to candidates and get. So there we've driven the very simple microservice API, and I think we're ready to proceed to actually doing the builds. So go back to the top of the page, and there should be links to the videos to the AWS, Azure, and Google Cloud Function, and we will do those now.